Hi guys, so lesson 2 of week 1 higher level functions didn't record the sound for some reason. It is on the iPad, but it won't let me upload the sound from the iPad for some reason to the YouTube link. So basically you can still use that video and follow it the best you can. Basically what I've done is I've gone through the homework and I've corrected a couple of questions. So I've corrected question number 3, and question number 3 is done out here. So question number 3, what I've done is I've taken the function and I've subbed in all the numbers. I've drawn the graph, which is a straight line down here, and then they asked us to work out. We had the function for t, what's the function for k? So I worked that out down here. So I subbed in for k, and I got the answer as 15/4. So that was question 3. That was question 3. We then jumped and looked at question number 13. So question 13 is down here because it's quite a difficult question. So it's all about a tennis ball being launched into the air. So you had this function here, and I made this table from that using the domain. It says graph 0 to 6, so I graphed 0 to 6. And I graphed it out. I got my x, got my y, and I drew the graph of the tennis ball. The first one was up here like this green line, okay? And then they asked us to work out what's the trajectory of the second tennis ball. So the second tennis ball with a different function over here, 1 plus 2t plus 1. So this works out as this graph here, the black line. So worked it out like that. And then they wanted to know what time the two balls collide. Well, the two balls are going to collide there with a black square is at 5 seconds. And then you can work that out by maths. So instead of subbing in 0, 1, 2, 3, 4, 5, 6, we sub into the new function. So we sub in 5 over here, and that gives us 7 meters. Or I can work it out as 7 meters over here. So I got 25 meters all the way across like that. And it gives me 7 meters. Okay, before I corrected these questions, obviously you can't hear it, but you'll spot it in the video with no sound, is over here you have the solutions. So what you should do is check your homework, see where you went right, see where you went wrong, then have a look at some of my other solutions. But the point that I do need sound for is that any ones that I didn't do that you had trouble with, so if there's any of these questions were homework that you couldn't do and you had trouble with, you can stick a message up and I will do them out on the OneNote. So I'll put them on the OneNote for you and put a notice up that I've put them there. Okay, after that then we went down here and we looked at greater than and less than, or greater than and equal to, those kind of things. And I went through some of these examples, and you'll see this in the OneNote as well. So these kind of things is whereas f of x is greater than g of x, or where f of x is less than g of x. So this example here says where is f of x less than g of x? And f of x is going to be down here. And it's less than g of x, it's less than g of x, it's less than g of x. It's the same as g of x. Now it's greater than g of x, greater than g of x. If you're wondering where g of x is less than f of x, well, g of x is greater than it here. It's greater than it here. It's, g of x is bigger, g of x is bigger. And then g of x all of a sudden becomes less than f of x. So that's just working it out and then using your algebra then. So we have f of x up here and g of x here. So we put them beside each other, and we can work out that x is equal to 8. So just using your algebra by moving your x's to the left and your numbers to the right. The other one's the same. The only difference is with this example here, you'll see it in the video, that you have a curve down here, which is a quadratic curve, and you have a line as well. So you end up, what you're looking to work at is over on the right side, the solution part. So whereas f of x is equal to g of x, well, f of x is equal to g of x in 2 spots. It's going to be equal to there, and it's going to be equal to there. Because g of x is less than f of x all down here, and it's greater than f of x up above where they meet. Okay. And what I want you to do then for homework, there's 2 questions there, question 2 and 3, but that's not all. There's 2 questions on that based on the greater than, less than stuff. And then this one here, which you won't be able to hear, but you can see, you'll see me doing it, is you have these exponentials, powers. So over here, you're used to these ones here, 2 to the power 4, 5 to the power 7, and so on. Whereas when we drew functions, we're used to getting quadratic functions or linear functions. But what if the function was 2 to the power of x? Or what if the function was 2 to the f, so f of 0 will be 2 to the power 0, f of 1 will be 2 to the power 1. So if they gave us the domain, x is somewhere in between 0 and 1, then you'd sub in 0 and you'd sub in 1. So 2 to the power 0 and 2 to the power 1. So basically the same deal. Everywhere you see an x, you sub in whatever number you're given, and so on. And then I went through these two examples here. So this one here, you have, in this case, you have p of x. And p of x is equal to 2 to the power of x. So down here, you have 2 to the power of x, and you sub in 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 2, 3, 2 to the power 4. Same as you would have done before, except this time you just have a power, an exponential. And you get your y values down here. Shouldn't have done that. Get your y values down here. And then you draw your graph. And these exponential graphs are not like U-shaped graphs or N-shaped graphs or straight lines. They're these weirdly looking curved things here. So you see down here, you have this strange looking curve in there. And what the questions they're asking you to do, so you graph them exactly the same, no difference at all. But what they get is, the question asks for, use a graph to estimate the population size after 2.5 hours of growth. So same as you did before, you go to 2.5. You go up to the where it touches the curve, you go in, and it gives you the answer. But because you have a look, this scale is in hundreds of thousands because you're dealing with the bacterial growth. So you multiply your answer by 100,000 to get the actual answer. If you're looking where p is 2.5, wherever you see the x, you sub in 2.5. So 2 to the power of x becomes 2 to the power of 2.5. And then you get this big huge answer here. When you work out the actual number. The last part of D was looking at the percentage error. So you're looking at, well, your actual value was 565,658. Your estimated was 57. So the difference between them over the actual gives you, multiplied by 100 over 1 gives you the percentage. Okay, so you can have a try at some of those. And I'm sorry about the sound. I'm not sure what went wrong there. This one here is exactly the same. I just put it in because if you have 2 to the power of minus something, it comes out as a fraction. So I said, right, I'll throw that in there just in case people are, well, oh, you have to come out as a fraction. But you can graph it as a fraction. So the y coordinate might not necessarily be 1 or 2. It could be a half or 1.5 or 2.5. So they can come out as fractions. So you're not wrong just because you come out with a fraction. Other ones I want you to do then is these ones here. So you've question 4, 5, 7, and 10. So you have 4, 5, 7, and 10 in 14.3, and you have 2 and 3 in exercise 14.2. Okay, there's your homework down the bottom there. So this is your homework that you're going to have to do for Friday. Those questions 2 and 3 in the first exercise, 14.2, and 4, 5, 7, and 10 the second one. Sorry again about the sound. I'm not sure what went wrong, but hopefully this video and the one with no sound will suffice. If not, come back to me.